In this video, we'll discuss how to see the distribution of our data. For this, we'll use this data set. This is the daily returns of 4 major stocks: Microsoft, Amazon, Apple, and Google. The data is from December 2014 to December 2017, last 3 years. You can download this data using the link below, or you can use your own similar data set to follow the example. Now let's load the data from our local drive. Here's returns CSV that we just saw. Choose the data. Once upload complete, check subset row to see all the rows are here. Also, you can check the columns under X variable and Y variable. Okay, all the columns are loaded properly. Now, in this example, we would like to see data from all the columns. If we use the default data, we can use only one column as X variable, the other column as Y variable. But this is not what we want. So we need to reshape the data. Check Reshape Data. For this, we'll select Date as a fixed column and then click Submit Change. What will happen is it will reshape the data to make it 3 columns. First one is the fixed column, second one is variable column, and the third one is value column. The data will look like this. So this is a preview of the data. The first one is the date column. Variable column has all other column names, and the value has all the column values. We would like to see the daily returns of all the stocks with time. To do that, in X variable, select date. Make sure the date is identified by the program. Check date. Date format. In this case, the date format is month, date, year. If the date format is different than this, you have the drop down to select the one that is applicable for your data. And under Y variable, select value, where you have all the daily returns. Since Y variable in this case is a continuous variable, we are not going to select discrete. If we select discrete, the program will consider this variable as a discrete variable and it will plot accordingly. Now here I have all the returns from the stocks with time. We cannot see that difference because they're all same color. What we can do to see them differently, we can apply color variable. So in this case, color variable will be our variable column where we have all the stock names. Then we'll click Submit. Now the returns have different colors by the stock. We can use the legends to see which one represents what. So here you can see the legends of different stocks. Now since they are pretty much in the same area close to 0. The other thing we could do to see it in a better view is to create subplots or multiple plots. We don't need legends for that. Check create subplots. So our subplot variable in this case is our variable. So the plots will be separated by the categories under this variable, which is in this case our stocks. Click Submit Change, and now you'll see 4 different plots representing 4 different stocks. They are also different in color since we applied the color variable. Now let's see the distribution of our data. So you can see the data is mainly concentrated close to 0. So it will be reflected in our distribution plots. The first one we'll do is histogram. Select histogram under plot type. Click Submit. And now you can see all the distribution in histograms, and they're separated by the stocks. Y-axis is the count, X-axis is the daily return. So you can see close to 0 daily return, we have the highest count. Another way to look at the distribution is frequency polygon. So you select frequency polygon under plot type, click Submit. Now you can see the distribution as polygons. Y-axis is still the count, and X-axis is the daily return. We can select density to create density plots. In density plots, X-axis is still the daily return. Y-axis is the kernel density estimate. If you'd like to see the data in box and whisker plot and compare the stocks side by side, we need to make some adjustments. And here you have your box and whisker plot. So these plots are based on 5 values. If you look at a single one, here is the data minimum, first quartile, median, third quartile, and data maximum. The individual points it estimates as the outliers. And outlier estimation is based on the interquartile range, which is the width of those rectangles or the distance between the first quartile to the third quartile. We can see the data as a Valin plot. Select Valin under plot type. And here is your Valin plot. Valin plots are a combination of box plot and density plot. It is a mirrored density plot displayed as box plots. We can also see the data as a jitter. This is another representation of the distribution as scatter plot. The last one in our list is the raster plot. It can locate data clusters. To see a raster plot, we'll go back to our previous setup. And here you can see the raster plot. The densely populated areas in your data shows in lighter color. And here's the legend to see what's happening here.